Hello, good morning, good afternoon, and good night, depending on where you found yourself in the world right now. My name is Inésio Langa. I have a bachelor degree in chemical engineering or process engineering from Universidade Eduardo Mondlane in Mozambique. I had my first opportunity in the energy sector through a training program in Samsung Heavy Industries in 2019. Now, 2 years later, I am working for the commissioning and startup team as a utility supervisor for the same project, the Coral South FLNG. Welcome to today's webinar, where we will talk about commissioning, which is the last episode of this second saga, which is brought to you by the Mozambican Woman of Energy to provide some information to young students, undergraduate, recently graduated engineers about the energy sector. Information that we know that it's not easy to find on the internet or on books in Mozambique. So for that, if you want more information, you can follow the Mozambique Woman of Energy page on LinkedIn. And if you want to see more videos like this, you can find them on YouTube. For those of you who are watching this for the first time and are not yet familiar with the Mozambican Women of Energy, they are a platform that brings women together through their energy and empowers them by providing the tools required so that one day they can hold positions of leadership and thus contributing to the sustainable development of our country. To achieve this, they rely mainly on two goals. The first one is to create a gender equality culture where both men and women can have access to the same information, education, and business opportunities. And the second one is that given that we are on an energy transition period due to the global warming and more big companies are favoring more clean energies, we want to provide equal access to sustainable energy to everyone, both local and urban areas. To achieve this, the Mozambican Woman of Energy relies on 4 pillars. The first one is think through research and projects. The second one is to build, where capacitates young engineers. The third one is to connect, where they organize events. And the final one is to lead by developing leadership programs. They have as partners the Mozambican Gas Summit, which is a platform that sets the direction and strategies of energy policies in Mozambique. Through providing information about the major players across the local and international value chain. Before we start this presentation, I would like to congratulate the Mozambican Women of Energy for their initiative into building the capacities of young engineers that will soon be the future of our country. For the presentation, if you have any questions, please do so through the Q&A section, and only use the chat for general comments. Without any further ado, I would like to present to you today's speaker, Maurícia Ribeiro.
Hi, everybody. Can you see me? Okay. So my name is Maurícia Ribeiro, but before I start my presentation, I would like to thank this opportunity to present what is commissioning by this organization, MWA. So I'm really happy to be here today and to try to explain you through my experience what is commissioning. So I'm Portuguese. I have a master's degree in chemical engineering from Universidade Técnica de Lisboa. So I was graduated more than 10 years ago now. So after my graduation, I was hired by a French company. So in fact, since then, I've been working for French companies. I start in a chemical industry. And 2 years after, I was hired by Technip Energies. So I've been working with Technip Energies since 2011 in the commissioning department. I had the opportunity to go abroad several times. Now I'm in South Korea for the second time. Last time I was working on Prelude as a handover and completion manager. I've been offshore with that project, which was a great experience for me. And nowadays, I'm working with Inésio in the utilities commissioning team as a utilities engineer. for the Coral project. So we'll go through the presentation now. I hope you can see everything. In case you have any issue, you can maybe ask through the questions in case you cannot see. So today, what we are going to talk about, so just to start a safety moment. So in fact, since I work in Technip Energies, we have this common habit to start all meetings with a safety moment, which is the moment that we can just sit and take a step back to think about the activities that will be ongoing, activities that may impact our way to work. So just to think about something that happened maybe in another project that can impact us. Then I will go in detail about commissioning. So just to start briefly discussing about the project phase where we can follow the commissioning. Then what is commissioning exactly, and what is the role of a commissioning engineer. We'll talk about handover and completion, which is a department linked to commissioning and construction also. Some HSE, which is really important for all site activities. Then we'll go through site activities, so through the width of construction activities. And then a little bit more in detail, the functional tests. And finally, the system operational tests. So just to start the safety moment. So here, so we can see a person that looks like he's trying to do a confined space entry. So first of all, something weird, he's not wearing his PPs, he's just wearing socks. He's using a colleague, I guess, to enter inside. So before planning any activity, we should have, first of all, a proper PTW, a proper way to do the activity, and this is not at all the way to do it. For confined space entry, we'll see later on, but so we need a proper isolation plan. We need a watchman, we need the proper entry, we need ventilation. I'm not sure there is ventilation here. So definitely not what we should see in the industry nowadays. So to discuss about commissioning, where can we find the commissioning in the project phase? So as a normal project, so you will have a phase from the engineering, so the design, then you have the procurement, construction, installation, operation, and even maybe some life extension, revampings, or decommissioning. So if we go a little bit more in detail, so what is a EPC? So EPC, it's engineering, procurement, construction. So here I will show you the typical project phase sequence for EPC project onshore. So we have first engineering, followed by the procurement, then the construction, and finally the commissioning. So commissioning is starting after construction, not exactly at the end of construction, but a little bit, we will see in detail later on, a little bit in parallel of construction. And after commissioning, we have finally the startup and operation by the operation team. For an offshore project, like Prelude in the picture, so same, so we have construction. So in this case, we have two phases. We have a phase at yard, and we have a phase that will be happening at the final location. So we have construction at the yard, followed by onshore commissioning. Then we have a sail away, as we see in the picture, it was the sail away. So basically, it's just moving with the tugboats or other means. This is for the you can have for maybe platforms. It can be directly inside in a barge. Then you have the hookup, which is all the phase for the connections offshore at the final location. So connections with the wells and any material that was not possible to be installed during construction phase at yard. And finally, you have another phase of commissioning, in fact, which is after hookup for all those systems that couldn't be installed before. And same as onshore, we will have startup and operations starting after finalizing all the commissioning activities. So this kind of sequence is also applicable for modularized projects, in fact, so similar like YAML projects in the remote areas where we built so basically the facility is built by modules and assembled all together at the final facility. So we can also have commissioning being done before at yard and after at final location, after installation in that case. And for offshore project, so basically here you will have, so subsea installation will be kind of in parallel of those phases. It's not exactly after or before commissioning. It will be, depending on the planning, it will be happening maybe at the same time, or at least it has to be ready when the facility or the boat or the platform will reach the final location. So what is commissioning exactly? So I just tried to put here in a couple of slides a few notes of how we can define commissioning, but later on you will see some pictures and movies of something that is more visual. So as we mentioned, so commissioning starts just after construction. Usually you will hear in industry that commissioning are all the energized and dynamic tests. So basically we try to test everything that we can as similar as we can as operating mode. And the idea is just to be sure that the plant was built according to the specifications and in a way that we can operate. So we do tests by disciplines. So just after construction, every discipline will take care individually of their elements, of their equipment. And once everything has been tested individually, we will, as system owners, we will test the globality of those items as a system. So as mentioned, we do it by system or subsystem level. Same, you will see a little bit later on in the presentation what is exactly this systems and subsystem means. The final target of the commissioning finally is to move from a constructed status, from an erection status to completion and acceptance. So meaning that we want to hand over the final facility to the client, which is the operations, who are the ones who will finally operate the plant. So this is our final target. Just to explain you a little bit what kind of organization you can have within commissioning. So this is just a bit general, then of course it will be depending on the type of the project and the size of the project, or even the client, what clients want. There is some integrated teams, but this is more generally speaking. So we have the commissioning manager reporting to a project manager. The commissioning manager will work closely with the handover and completion team, where you can find engineers and clerk, meaning so people working with the database. We will see also what is exactly this handover and completion after. So the commissioning manager will work closely with the HSE managers and engineers to be able to apply all the HSE policies of the project and to be sure that everybody works safely. And as we mentioned, every time we want everybody to go home at the end of the day, because that's the most important of the job, is to be safe. So we have planning engineers working with the commissioning manager. We have subcontracts engineers for everything that cannot be done by the contractor. So there is some specialized activities that will be subcontracted to dedicated companies that will come just for those specific activities. He will manage also vendor coordinators. Vendor coordinators will coordinate, as the name says, they will coordinate the vendor mobilizations on site. Some of the commissioning activities require the vendors. It means you cannot start if the vendor is not here, because they can just cut the guarantee period, for instance. It's mandatory in the contract for them to be present as soon as we want to run their equipment. So with the commissioning manager, then we have several teams. One team by discipline. So we have an electrical team with engineers, supervisors, and technicians. Among all the teams, we'll find those engineers, supervisors, and technicians. So basically, engineers are the ones who are more or less planning the activities. Supervisors, as the name says, supervising the activity, and the technicians, it's kind of helpers with tools to help on site to achieve the activities. So we have an instrumentation and system team. So this team can be, in fact, can be two teams, depends on the type of the project. Same mechanical and HVAC can be also two teams or just one. Telecom engineers, then utilities and process. So utilities and processes more or less as they are more or less that system engineers. System engineers, I mean, system. They are owners of the systems of the facility on utilities and process sites. So basically, they are the ones. They are focal points for the entire subsystems, and all the plant. We divide it between utilities and process. And the operators that we see here depends on the project. They may be allocated to an operation to a dedicated operation team. Otherwise, here we are just talking about operators to support the commissioning activities, not the final operators of the plant. So if we want to resume exactly what is the commissioning, what is the role of the commissioning engineer? So basically the commissioning engineer can be mobilized at the home office. So meaning before starting the construction at engineering phase. So this in order to prepare the commissioning deliverables. So all the procedures that will be required to perform our activities on site later on. To prepare all the subcontracts that we need, whether for specialized activities or for modularized projects where something will be done by a yard, for instance. During this engineering phase at home office, basically our role is to discuss also with the engineering departments and to review their documents, and if there is something that can impact us or for some reason we need a modification and the way the design is built today doesn't allow our activities. So we try to anticipate any potential issue we may face at site and to try to implement it already at engineering phase. We will also help for the preparation of the database that will be used for the completion process. So it's the database where we will be able to find all the activities listed by systems and subsystems. So in fact, it's a summary of all the activities that we have to perform under the contract. Also, one of our roles when we review, when we do our preparation at home office is to be sure that we have all the material required, and if there is any temporary material or arrangement that we need, we may want to start planning some procurement for those temporary materials. Or also, as I put here, One of the examples is, for instance, at yard or even onshore. At the beginning, we don't have energy, we don't have permanent power. So we need to think about a way to have temporary power until we commission the electrical part, until the substations are available and we have power for our consumers. So we need to have kind of a temporary power source. Depends on the projects. We may also attend factory acceptance tests or final inspections of skids and package at the vendor workshops. We will plan also the mobilization of people on site, of all this commissioning team. So as I was mentioning, so we will review all the material required for the commissioning and start the procurement phase. And after this phase, so the engineers are mobilized on site. So nowadays, depending on the projects, but we try to mobilize the engineers quite ahead of the commissioning during construction phase. This because sometimes we didn't have time, or when we are at office, we cannot plan everything. And when we are at site facing the real conditions, we have other thoughts. And finally, we need to update our procedures. It's a good way to be familiar with the installations to come at the construction phase. We will witness some of the construction activities that may have an impact in our commissioning, or some activities that we don't want to repeat. So if we witness it once, we will be free after during commissioning. The commissioning engineers will be during construction. At the end of the construction, they will attend the walk downs. Walk downs are a way to walk through the system, through the construction system, and to be sure that there is no defect, and to be sure that we receive the system in a good way for commissioning, and that the construction is really completed and there is no major defects or non-conformities. And finally, all of these resumes, so we need to prepare and start executing our commissioning activities. So for commissioning, you will see this is for all the projects. So we use a system-subsystem approach. So what is this system and subsystem approach? So the numberings you will see hereafter are depending on the contract and on the numbering philosophy. So this is just purely an example. So imagine, so you have your facility. Among your facility, you have several units. So a unit might be the, if we take a LNG, might be the liquefaction, might be the warm. So we may have only, we may have like a mercury removal, then the dryer section, then the HRU, so all those units. So we divide those units in single systems. Then in smaller, we divide it by subsystem. And the idea is to have subsystems, so including equipment inside, in a way that you can perform activities all together. What I mean is like we need to have a breakdown of subsystems in a way that allows commissioning, and in a way that you are not dependent from other subsystems. So finally, in the subsystem, so you will find all engineering tasks that will be allocated to those subsystems, and ITRs, which are the inspection test reports. So it's the inspection test reports. It's the reports that we use for reporting the results of our activities during commissioning. And this, in fact, you will see it in the handover and completion tool that we'll see some slides after. So basically, the system-subsystem approach is the base of the commissioning. So this will allow us This example here is, so imagine we don't have this breakdown approach. So it means that this is an example taking, like, if we have a subsystem starting construction, then we go to commissioning and we go to startup. So it means we need to have full construction finished until we can start commissioning and then startup. With this breakdown approach, we talk about subsystems, not about facility as the example in the top. And we do by subsystem. One subsystem reach construction finished, we can move to commissioning. Another subsystem moves to finished construction, we can move to commissioning. We don't need to hold up the beginning of the commissioning until we have all the subsystems. So at the end of the day, we will have this time benefit that we wouldn't have if we don't use this system and subsystem approach. So just to give you examples of what is exactly those systems and subsystems. So commissioning and handover team, they will keep some master files of, for instance, all engineering documentation like single line diagrams or PIDs. Just a second to open the. So here, in fact, the colors are the subsystems. So what we do is quite easy, in fact. So we take, so for electrical, this is an example for electrical systems. So we take, this is a single line diagram from the high voltage to the low voltage. So we take every individual element and we allocate it to a dedicated subsystem. So here, let me just show you. So here, for instance, we see that this battery is fitting in this subsystem number. This one here is in another subsystem, this one in another subsystem. So what this means is that if construction is completed on this site, but not on this one, neither on this one, neither on the pink, we can start here on the 02. But if the facility was not break down by subsystems, we would have to wait for every single one to be completed until we can start something. So this is pretty much what we call system subsystem approach. And an example here with the PID. So for instance, so we have a vessel here. So this vessel belongs to a subsystem 490.01.01. Here we have some supply and return lines belonging to different other subsystems. Here's some instrumentation also to another subsystems. So basically, like I was saying, so here, when construction is completed here, we can just start our activities and we don't need to wait for everything to be completed. So now talking a little bit about handover and completion. So handover and completion depends on the project and depends on the clients and also depends on the companies. It may be linked to the construction manager or to the commissioning manager or even to the site manager. The projects I've been working on, most of the time they are linked to the commissioning manager. So in fact, the handover and completion department are responsible to follow and to track all the milestones of the project up to the completion of the project. Milestones linked to systems and subsystems. It's not a contract. I mean, it's contractual milestones, but not every single milestone in the contract. Only the ones related to final acceptance of the facility or the plant. So, for instance, here we can see that this is just a typical example. So, after finishing construction, sometimes you may hear about pre-commissioning or not. You have a milestone called mechanical completion. Once commissioning is finished, we talk about ready for startup. Once all startup has been done, all startup activities, there will be a milestone called provisional acceptance, and finally, final acceptance. So the projects I've been in with Technip Energies, we need to have a representative up to this final acceptance certificate. And gradually the responsibilities are changing from contractor to company, especially at this phase here, RFSU. So here we can see during the construction and commissioning, we have also the punch list being generated. Punch lists are all the defects when we do inspections, all the defects that we may see. So everything is listed and will end up in the Handover database. And also here there is we can see like during construction, so we are working with a construction permit, commissioning with the commissioning permit, and finally we move to operational permit. So a little bit more in detail, what is a handover and what we can do within the handover team. So the handover, so they will be in charge of populating a database. So inside this database, they have to register all the tags, everything that is tagged inside the project. So every single cable, every vessel, every pump, every instrument, everything that has a function or everything that is physically something will appear in this database. And for every item that there is an activity, we will see an inspection. So we will see kind of this, so an inspection ITR, inspection test report. And when people on site will finish their activities, they will just tick here if it's how the test was done, successfully, not successfully. If they have any remark, they will put here, and everything will be compiled and sent to this team, to the handover and completion team. So during if there is a defect, they will use a form like this one to register all the punch items. The punch items will be categorized. It depends on the project. You can have category A, B, C for the type of defect and when you have to solve it. And finally, every time you have a milestone, you will have a dedicated certificate. Like this one is just an example of a certificate between construction and commissioning. So basically this handover team are the ones that makes the transition between construction commissioning and then commissioning to operations. And they have to put everything we do on site in this database. All defects we will find, everything will have to appear here. So one important thing, or I will say the most important when we are on site, it's HSE. So just a little bit about HSE. So all commissioning activities requires a permit. A permit that has to be issued at least a day before, that will be reviewed during a SIMOPS meeting. During this meeting, general authorities will check if there is conflict between different activities. TBM, it's a tool we have. I'm not sure it's used in all single projects, but at least the projects I've been in, we use it. So it's basically a brief discussion we are having with our team of technicians and supervisors before executing any activity. We make sure that everybody understands the job and everybody knows what to do and how to do it. And especially if they have something, maybe something personal or something they have to, it's a way for them to speak with us to understand if there is something preventing them to work in a safe way. So one of the measures we have with the HSE department when we do activities, it's the LOTO, so lockout, tagout procedure. So to prevent some of the some hazards when we do activities, sometimes we need to isolate our systems with physical boundaries. So we use a system of keys, in fact, to isolate the systems. So here, for instance, in the picture, we can see an electrical technician. So he performed a rack out on the MCC, and he's just installing the lock to be sure that we can work safely and nobody will power up the motor. So here we can see for this same isolation. So we have isolations on the valves. So we have the locks. So nobody can come and open the valves. They're not able to be operated. And all the keys we use for the isolations will end up in a box like this one. And only the permit, so there will be a key owned by the permit holder on the box. And every discipline that has an isolation will have a key. So we cannot de-isolate unless if we have everybody agreeing that the isolation is safe to be removed. So this is one of the measures we have in place in most of the projects to protect ourselves during SIMOPS activities. So in fact, this electrical and this piping isolation was meant for dismantling of a safety relief valve for calibration, where we had to be sure that the motor was not running and that nobody was going to open or close any valve after our job. So to be able to perform commissioning activities, we need to use a commissioning permit. So how can we move from construction permit to commissioning permit? So as we said, so at the beginning, we are in the construction phase with the construction permit. So we are here. So once construction is completed, so this is an example for a subsystem. So once construction is completed for a dedicated subsystem, so we have a milestone, which is mechanical completion. So the name of this milestone can be another one, depending on the type of project you are working on, or depending on the client, or depending on the contract that you have to apply. But let's call it now mechanical completion. So once you have reached mechanical completion, so you have construction and commissioning signing on the certificate. What we will do is, so we will check if there is any subsystem close to the subsystem that is just about to be commissioning, that is still under construction. Meaning that if we have, so this is the subsystem that we want to work on, but here we have construction people working. So we need to make a proper boundary isolation. In case we have a leak of energy, means type of energy, meaning power, fluid, or heat, or whatever, we are sure that we will be able to isolate it from construction people. So everybody can work safely on both sides. That's the idea behind this. So after installing our boundary isolations, we do a proper walk down of the system with the HSE. We issue what we call a lightening up notice. So meaning that from that point, from the signature of the commissioning manager on this form, we are now allowed to issue a commissioning permit. So therefore starting our commissioning activities. So going now a little bit more of what we do on site. So as I mentioned previously, we are mainly asked to come sometimes for witnessing of construction activities to be sure that we receive proper systems completed and achieved and no problems. So for instance, strainers inspections is one of the activities we witness. So here we can see a small strainer that was damaged, in fact. So this is another type of basket strainer. So basically during those inspections, what construction does is just they show us the strainer, we check if it's cleaned and if there is no damage, and we install it and we box up with the final gasket. Something we also do is checking of the spring supports. So spring supports are, as the name says, it's not fixed support, so they can hang a little bit, depends on the fluid you have inside. So basically we check that the support has been released, meaning that those pins have been removed. We keep the pins in case we need to put it back later on for maintenance or maybe because of towing in this case. And we check also if here we cannot see properly in the picture, but there is a arrow showing us the cold setting and the hot setting to be sure that the spring support has been correctly released. We also witness internal inspections and final box-ups of any kind of vessels. So disinfect. So I have here a couple of pictures. So we can see here ventilation through the manhole. So here in this picture, it was not exactly final inspection. People were still working on. Here we can see that there was something left inside. So hopefully we did the inspection and it was removed at the time of the final box-up. One important thing when we do those inspections for vessel inspections, especially the confined space entry, permit work, and isolation. So we need to be sure that nobody will be able to put any kind of energy inside our system. We will be fully isolated, and there will be no fluid connection, nothing to. So we need to be sure that nobody can connect anything to our system prior entering the vessels. We need to measure oxygen. Sometimes there is some portable devices that we can wear to be sure that oxygen inside is suitable for life. Before entering, there is a watchman outside, and we have to put our tag just in case to be sure to know who is inside. Or sometimes vessels are small, but they can be bigger, and just to be sure exactly who is inside. And we are not closing by mistake, or if there is an accident or something, we need to be sure who is there. So last step before starting our commissioning activities are the walk downs. So we do a joint walk down using those kind of drawings. So we use engineering drawings like PIDs, layouts, single line diagrams, depends on the type of facility or discipline we are inspecting. So basically we work with our construction team. We work the subsystem that they are telling us that is nearly ready to be handed over to commissioning. We try to check every line, every cable, everything to be sure that everything is according to specifications and there is no major punch item that will impact our activities to start. And at the end, so there will be the certificate will be signed with any listing of the defects that will have to be rectified after commissioning. Or otherwise, we will tell them that for a certain amount of items, they will have to rectify before because it has a direct impact in our activities. So going now more deeply inside commissioning. So commissioning, we can divide it in functional tests and operational tests. Functional tests are all the tests being done individually by the disciplines in every single equipment. So instrumentation team, they will do tests for all their instruments. The electrical team for all the electrical device. Mechanical team, they will check pumps and some stuff like that. So going a little bit more in detail. So for the electrical teams, what they do is, so one of the big jobs of the electrical team, especially to energize all the cabinets and all the substations in order to have power for the entire facility. And during commissioning, our idea is to go to a level of operation for electrical systems to start then using the normal power and not any temporary power. So electrical team, they will do pre-checks prior energization. They will conduct conductivity cable checks and paper checks. They will do some earthing checks. And once they finalize all their checks, they will be ready to energize UPS. and finally to energize their substations. So here in the pictures, we can see one of the substations with panels. Here in the bottom, we can see some electrical engineers doing some tests here in the panel. So for the consumers, electrical teams, they will do also some pre-checks. So consumers, like all these consumers, are all the motors, basically, motors or sockets or lamps, everything that will receive energy, in fact. So electrical teams, they will perform electrical checks. So here in the picture, we can see electrical technician inverting the cables inside the motor. So we have tried to do a run of the pump, and the motor was rotating reversely. So they are now just inverting the cables. For instrumentation, we have something similar as the electrical, but without this high voltage power. So we do some pre-checks, prior energization. Then we have energization of the instrumentation cabinets. We do loop checks, which are individual checks of a loop functionality in process or utility systems. We do functional tests, which are related also to process and utility systems. They will check all calibrations of safety devices as PSP and rupture disks. There will be fire gas testing and telecom testing, all the communication systems, radar, navigation, cameras. So here we can see just a DCS picture. So basically after they do all their cold SAT and the SAT cabinet, we start having access to the DCS and we can start doing activities with interface with the control room. So here just examples of safety pressure valves that will be calibrated by the instrumentation team. So now going into the operational systems. So as mentioned before, those operational systems, in fact, there will be, so it will be the engineers from utilities or process team who will be in charge of those activities. So that's where I belong, in fact. So here is just some examples. I couldn't list everything that we do, but it's just to give you an idea of type of activities we can find in our industry. So mechanical run tests. So all rotating equipments are meant to be tested. So it can be fans, agitators, compressors. So during commissioning, we want to be sure that the device, the equipment is properly designed and can run according to the pressure, flow, temperature that was meant for it. That the performance curve of the pump is that the pump is running according to the performance curve. We verify vibrations and steam temperatures of the equipment to be sure that they are within acceptable limits. So here in the picture, we can see somebody measuring the temperature with the thermometer gun. So here we have a vibration measuring during the test of the pump. So these both measures are during the life test of the pump or the compressor, for instance. So here, just a small movie about so it's a hot oil pump in the project I've been working. Just so in fact, won't see much, but of course the pump is behind here. So before, like I was saying, the project person about what is going to water and what is organized. sometimes for the mechanical runs, we will start locally from the site or directly from the control room.
Ready? 3, 2, 1, start. 2, 1, start.
Here you have just hear the sound of the motors of the pump. This is when I start feeling
Okay, the pump is running. Discharge pressure around 30.8.
in the movement. It was started from the control room. So those tests depends on the type of motor. We run 2 hours or even 4 hours, depends on the projects. So here just an example of some temporary arrangement we may need when we do our tests. So for instance, here on the PID, so the idea was to test those 2 pumps. And as per current design, since the subsystem here and the lines were still under construction, so we had to use a hose for recycling inside the tank. So here in the picture, those 2 pumps are those ones. And here is just the installation of the hose. So in fact, if you one day you come to this industry, you will see that sometimes you spend more time for the preparation than for the test itself. So for operational tests, we can also find the dynamic flushings. So dynamic flushings will be on all kind of closed loop networks, such as cooling water, thermal fluids like glycol or hot oil. So here we can see in the picture, so the filter. So this is a cooling water system. So in fact, for this flushing, basically what we do is, so we fill up the system with water, and the system will be continuously running with the permanent pumps. And as soon as the strainer are plugged, we'll just stop the pumps and clean the strainer. That's what we do in those dynamic flushing. We call it dynamic flushing since we are using the permanent pumps. Here we see from the inside where this strainer was. So here are just, this is where you pull out the strainer, in fact. And we do those kind of flushings not only to remove all dirt inside, but also because sometimes we find some strange things inside. So here there was a plug that was left inside when they finished the construction. So here just a small movie about, so this is a hot oil system. They are removing the filter that we they are just pneumatic tool. So you see now they have changed also. They have proper PPEs for handling chemicals, because this one was not water and hot oil, so they will wear PPEs accordingly. So they have face masks and plastic PPEs. Then the cleaning method of the strainers will be can be brushing or with well, here it's hot oil, so it will not. It has been done with air strainers on clean water. We can do also with brushing and with pneumatic air or directly with water, depending on what we have available in the facility. Sorry. So another type of activity that you can find, so in fact, all those activities I've been talking about, this is not only for onshore, you can find it not only for offshore projects, you can find it also in onshore, this, so chemical loading, for instance. So important thing about chemical loading, it's not the activity itself, it's especially all the means we put in place to perform it safely. So we need to issue a permit to work, of course, with a material safety datasheet. Those datasheets needs to be available for people on site to know what kind of material they are dealing with. They will wear suitable PPs, depending if it's a chemical like acid or if it's just something mixed with water that there is no real troubles with it. So they can wear breathing mask or special gloves, like for acids, everything with the plastic, rubber boots. Even if we take all our measures, we want to be sure in case of there is a spillage, we have always spill kits around. So these are basically absorbents. So it depends on the type of chemical, we need to select them according, like if it's for oils or for water-based chemicals. We will have safety showers available in the area where we will perform those chemical loadings. Here are examples of retentions that we may use. So here is just a temporary one for oils. Here it's a temporary one also. Here a temporary one for IBCs. And here it's a permanent one, in fact. So the retention is all here that you can find. Basically, if there is a leak coming from the top, it will be retained in this area. And after we will clean up or we will remove it through a pump, or depends on the type of the retentions. The loadings, we can perform it manually. We can, with a can, for instance. That's what we see here, the person in the picture. So here you can see he's wearing proper gloves, proper PPs, full PPs, a mask. He has also a breathing mask. So here he's using a can. We can do loadings from IBCs, from tankers, from ISO tanks. Those are just examples. Again, it will depend on the type of the project and type of facility and where is exactly the storage. But at the end of the day, what we want is to fill the permanent storage with the chemical. Catalyst loading, an example of molecular sieve gas dryer. So here you have a column with different types of fillings. So you have some ceramic bowls. Around here you have the meshes. Here some absorbers. So this is pretty much how it looks like from the inside of the vessel. So during commissioning, we will have to fill up every layer, in fact, and after filling, since this one is only used for once we will have oil or gas inside the platform, we will just preserve the vessel with nitrogen to be sure that it will not get wet. So here for these kind of activities, so as mentioned before, it's similar to a confined space entry because even if it's not for an inspection, we need to enter inside to properly route the catalyst we are loading. So we need a proper isolation plan. So isolations are made like this. We take the PID, we take all engineering documents that where we can see all the boundaries. With the dedicated permit to work, there will be oxygen monitoring, suitable PPs, depends on the type of catalyst we are loading. Here in the picture, we can see, so this is the vessel we were charging. So we can see proper barricade. And here we have a watchman, and here, so this is the hopper. And here we have a person that will receive the bags and will be sure that it's correctly going through the hopper. And of course, we keep always communication during the activity. So here, just a schematic examples. We have the hopper here where we'll be loading. And here we have the flexible sleeves where we'll be filling, and there will be somebody here inside just directing the flux of absorbers. So this example is for a vessel that we are filling from the top. You may have vessels that you need to fill from the bottom. So here is just an example of so the material we had to fill inside. So here a small movie about the loading. So this one will take a little bit more time than the others. So here we just see the bag being lifted. So here they are using the permanent lifting facility. So again, depends on the type of means you have on site. You may use something differently. This is because it was available, so it was suitable for us. Just maybe accelerate a little. So here we see the bag still being lifted. So now the bag is at the top of the hopper. Just try to accelerate. So now he's just directing. So now the filling will start. So we have one person inside the vessel. Also, when we do entries, of course, proper ventilation plus you can see the access to come in and out. And now the filling is ongoing. And finally, the filling has been completed, so the bag is going back, and there will be another one if depends on the quantities you may charge. Of course, you may have several bags, so next one will come after. An example of other tests, marine loading farms. So this you will find especially in offshore projects like LNG projects. So what we do during commissioning is to test that the arms are correctly positioned as if there was a tanker coming for the offloading. And we do some emergency test release in case you have the tanker and you need to release automatically. So this is a movie from Prelude Project.
Okay, easy two in 3, 2, 1, go.
So you can see that the release was done successfully.
Okay, easy two in 3.
Now safety systems. So here an example of lifeboats free falls. So as I mentioned before, we need to test every single system. Offshore projects, if those ones are not working, we cannot sail away. And definitely this one was not working. Something went wrong. This was not on a project. So definitely they will have to work on it. And final test also on the, so this is a deluge. So all the facility, no matter if you're onshore or offshore, you will have fire water all around. And we do deluge tests with the monitors and hydrants. In fact, we just confirm if every area are being wet as it is supposed to be as per design, in case we have a fire. Movie is not from a project I've been working on either. I just also from a youth. And that's it. That's what I have prepared as for this presentation. I hope you have enjoyed. And so if you have any question now, I think we can go check with Inésio if we have all the questions.
Hello. So first of all, thank you for the amazing presentation. I hope everyone enjoyed as much as I did. Before I go to the Q&A questions, I actually have a couple of ones.
Okay.
So first one is, what was your biggest challenge that you have found during commission?
Biggest challenge?
Yes.
I would say sometimes we get frustrated because of the time we spend on preparation. And so I will say to beat myself against all this frustration during commissioning sometimes, yeah.
Okay. And the second one would be during the offshore commissioning. So what are the extra precautions that are taken, considering that especially the addition of some systems that were not operational and before on onshore?
You mean precautions like safety precautions or?
Yes. Safety precautions.
So in fact, when we were offshore, for instance, my experience on Prelude, so we were already in operation mode. So in fact, you couldn't bring anything that could cause sparkling, for instance. You like watch, cell phone, everything had to be ATEX. We had to inform every time we were doing an activity, we had to inform control room. So we were more or less under the control of operations, in fact. So
okay. Thank you for your answers. Now to the Q&A. Someone has a question that what are the main differences between the pre-commissioning and the commissioning phase?
So in fact, it will depend on the type of the project. When I said the type of the project, so mainly when you work on commissioning, you will see that the definitions depends on the contract. So it depends on what company wants. Sometimes a company defines that pre-commissioning is something, and you will see in another project that it's another thing. But generally speaking, in Technip Energies, pre-commissioning is everything that is not energized. So it's pretty much as end of construction, like final inspections. What I've shown as strainers inspections, final box ups, within Technip Energy, we consider it pre-commissioning. So it's everything not energized, all walk downs, PID conformity, just before starting commissioning.
Okay. And the next one is, I would like to know, in terms of activities for a FLNG project, what are the kind of activities performed during the offshore commissioning?
So offshore commissioning, so we will have, for instance, seawater lift pumps that will be installed offshore. So we'll have the run of the testing of those pumps. After, we will have also all the drying of the facility. So we do a defrost. So basically it's drying with the gas. So it's kind of commissioning already with gas, in fact. So, and depends on the clients also. So you may have the, so it depends on the clients and on the engineering behind. So you may have machines like turbines that are rotated by gas. So if you want to test your turbine, it can only be done offshore, like gas turbine generators, compressors run with the coupled with the turbine, those kind of elements that you'll only be able to do offshore.
Okay. And one more, how is the high pressure leak test performed in this kind of projects?
So same high pressure leak tests will depend on the requirements of the client. So you may have a leak test. Most commonly, it's nitrogen with the helium tester. So we just sniff the flanges with the dedicated device, and we measure the leak through this device with the helium. Or you may have only nitrogen testing, HPLT with nitrogen. And then depends on the client and on what the client wants. You may have all the process part being tested, or there might be some exceptions, something not being tested. And again, depends on the client. You may have some HPLT done onshore and partially repeated offshore to be sure that no flanges has been moved during the towing, in fact.
Okay, I think those are all of the questions. But before we end, being that this is the closing of the saga, what is the relationship between commissioning, engineering, procurement, construction? So what role does commissioning have in the interrelationship between all of these facets of the EPCIC contract?
So at the end of the day, we just want to have a project successfully achieved. So we just want to hand over the keys to our client and to be sure he can operate his plant as for what it was designed, and especially safely. And that at the end of the day, everybody goes home safely.
Okay, thank you. I think that finishes today's questions. So with this, we can close our section. Thank you today, everyone, for attending this section, and we will see you on the next saga.
Thank you.